Today we are going to tackle an essential skill for every data professional, and that is data modeling. And we're going to be doing that using Power BI. Have you ever been overwhelmed by a massive spreadsheet? Yeah, I know how that feels. Well, in this video I'm going to show you how to convert that chaos into a clean and efficient data model. We will take a single flat file from a spreadsheet, bring it into Power BI, and break it down into, dimension tables, creating a star schema. But why is this important? You see, data modeling and normalization helps improve the performance of your queries, makes your data easier to understand, and of course, makes it easy to gain more insight from your data. So, by structuring your data properly, you can reduce redundancy and ensure data integrity. In fact, they can make writing DAX more efficient and easier. Yeah, I know this is a high-level introduction into normalization, relational databases, data modeling. So if you are not so familiar with these concepts and you want me to record a more in-depth video on this, let me know in the comment section. However, I have added the spreadsheet file in the description below, so feel free to download it so you can follow along. So grab your laptops and let's do this. All right, and here we have the the flat file in CSV. We have it here, so let's just transform. So what we're gonna be doing is we're gonna be using Power Query Editor, or where we're gonna do all our manipulations, creation of the dimension tables and the fact tables. All is gonna be in Power Query Editor. All right, so here we have the old data. Have it named sales data, and we can see here quite a number of columns are here. This file actually contains over 700,000 rows. Okay, so way to check is to come here and place the make the column profiling based on the entire data set. So here is based on the top 1000 rows. I'm gonna make it based on the entire data set. So we go to the view and do a little bit of EDA. Now, one thing here, because the data is quite huge, and these are one of the issues with a big working with a big flat file or a huge table. The software you use tend to have issues because it's not optimized. It takes forever to run. So have that at the back of our mind while we try to do EDA here. So what do we go with now? Let's pick the column quality first, and let's see. It's taking quite some time since it's it keeps running. So let's reduce it to the top 1000 rows. So we assume that we've got 1000 rows here. You can see it's quite easy to run, because the number of rows has reduced. Let's check the column distribution. You can see here. Let's see the column profile. 1000. This is just to look through the data initially. So let's come back to to the business of the day. So what we want to do is we'll have our fact table, and create our dimension tables, right? The first thing you want to do is you need to conceptualize which of what's going to be our dimension tables, right? What are the tables? Which of these columns are going to make up our dimension tables? So a way to look through this, an easy way to look through this is go to choose columns, and let's check out the columns. So we have them here, right? Now we look through all these columns. How many dimension tables can we break this down into? But first of all, what are the fact tables and what's a dimension table? Now from this table, the fact table is contains the values or the data that you want to analyze, right? And we can also say that fact tables contain numeric values, right? Numbers, things that you can analyze, like salary, like total sales, like unit price, cost, profit, all those things that you want to analyze, they are contained in the fact tables, right? So the fact table contains numeric values. So if you come here and you look at it, so okay, something like unit cost, unit price, and the likes should be in the fact table. Okay, And dimension tables, dimensions contain descriptions, right? Descriptive data, that tells us more about, all these the numeric values you have in the fact table. We can also say in another way that dimension tables contain the attributes that you will want to analyze the fact table, the values in the fact table by. For instance, now let's say we've got unit costs or unit price or something like as we have here in the fact table now. So if we want to analyze unit cost, how are we going to do it? So we might want to analyze it by customer. You want to analyze unit cost by product, by location or something, right? So all those customer, product, location, so those are the things that are held in the dimension table. Now looking through this place, we have the product ID, we have the product, the customer ID, the campaign ID. So when we go with the product ID, that's so we can create a dimension table for product that will hold product ID, product, category, segment. Can create another one for customer, holding the customer ID. What else now? Email name, yeah, I think. Then we can create another one for what else? Yeah, we can see a bunch of locations here. That should hold the zip code, city, state, region, district, country. That makes up 3 dimension tables. We have dates here, so we can create another date table, right? Create a date table for the date. So that's basically what we're gonna do. Now the first thing to do here is let's rename this and say let's call it fact sales. Okay, so the next thing we want to do is we want to remove every descriptive attribute in this large table, right, for a specific category. Say every descriptive attribute about product, we'll remove it and we create another table for it for a dimension. Every descriptive attribute about customers, we bring it out of this table, we extract it from this table, put it in another table called dimension customers, and like that. Okay, so let's start with products. Now let's create our product dimension table. One way to do this is let's come here, we're gonna duplicate we're gonna duplicate this. Let's duplicate it a number of times, corresponding to the number of dimensions we want to create, but I think we want to create 4 dimensions, but let's duplicate it thrice first. So rename this and we'll call it dimension product, right? Come here, let's rename this dimension customer, right? And the third one we say dimension dimension location or geography or something. All right, so let's work on each of them. So what we're going to do is we come to choose columns and we choose the columns that pertain to product. So let's select, let's unselect all this. Of course we need the product ID. Now what the product ID will do, because this is a dimension product table, right, it means that the product ID should be the primary key for this dimension table. So it's dimension tables that have primary keys, right? So they will have the same column in the fact table, but in the fact table they serve as the foreign key, right? So we pick the product ID. What else tells us more about the product? Yes, perhaps the product name, category, segment. What else? I think that's it, and we are good. So this is it. Okay, now because this is a dimension table, we don't expect any duplicate. This is just telling us descriptions, telling us more information about it. So if we have a single product ID here, then every other thing that tells us more information, it's enough. We don't need it to be replicated, right? So what we do is we remove control all and remove duplicates. Okay, I think so then we can now check. We hope this runs. So if we have it here, but we need to take note of this. The column profiling is based on the top 1000 rows, so we need to place it based on the entire data set. So what we are trying to look at is After removing, duplicates, what we expect that because we expect that we want this primary product ID to be the primary key, then it should be unique, not just distinct, right? And when we put the profiling based on the entire data set, we have 212 distinct and 212 unique. So a way to know if a column is the primary key of a table is that it's going to have equal number of distinct and unique values, right? And that's what we have here. So it means the product ID is the primary key. As you can see, it doesn't happen in other columns, which is okay. So this is our dimension table for the products. Now we come back to the fact sales, because one of the things we want to do is we want to reduce the quantity, the size of this fact table, right? So we come here and we remove everything that has to do with products, leaving only what product ID to serve as the foreign key. So come and use the same technique, choose columns. So what do we do now? So we leave this product ID, then we remove the rest, products, category, segments, and that's it, right? Remove this, get this off. Yeah, so we have our dim product already. So we'll do the same thing for the dim customers. So like you might have thought, we come to choose columns, we choose everything that has to do with customers, of course the customer ID, and I think email name, and that's it. Okay, so we'll come back to the fact table and remove those columns, leaving only the foreign key, right? So we leave the foreign key, which is customer ID, and we remove the email name, and that's it. So we come back to the customer table, and let's do a little bit of manipulation here. Email and name are joined together, so we split it. Come to split column by delimiter, and as you can see here, the delimiter here is the close brackets, column and space. So come here, we say close brackets, column and space, right? And that's it. That should work. Yeah, that works. We come here, let's rename this as email. Okay, but of course we've got another open parenthesis here. So what do? We replace it with nothing. Come to replace. These are basic Power Query stuffs. Another way to do this, we want to split this to first name and last name. Come to split column by delimiter. Now we have comma here. I don't want to do comma. If you want to split by comma, it means that the name after the comma is going to be preceded by a space. So we say custom, and then we split it. Delimiter will be comma and a space. So that trims it off, and so let's rename this as, say, first name, right? And rename this as last name. Good. So we've cleaned this table already, and we are good to go, right? Yeah, one other thing we've not done, remove duplicates. Should always remember that. Let's move on to location. Yeah, let's move on to location here, and what do we want to do? Let's remove this column distribution. We'll do the same thing, choose columns, and we choose only columns that has to do with location. And of course, we always remember that whenever we are choosing columns for dimension table, we should always note what will stand as the primary key, because that's basically what would responsible for the relationship, right? So what would be our primary key here now for this location? It must be the last detail in your table, and of course that should be the zip code, because after zip code, I don't think zip code has any other subset or something. A city can have many zip codes, right? So zip code should be the primary key here. City, state, region, district can contain a lot of states and city. Countries, of course, can contain a lot of districts and regions and all that. So zip code is most appropriate as the primary key. So we've picked every other thing that has to do with location, and we say okay, and here we have it, right? And of course, remove duplicates. Say Control A, remove duplicates. Okay, so let's also view this as well. Just to confirm, based on the top 1000, let's say based on the entire data set. And what do we have? All right, as you can see, this is serving as our primary key. You can see 29,000 same. So it means this is very unique and we are very good. So we come back to this fact sales and we do the same thing. What do we do here? We remove those location columns that will do locations. So we leave the zip code, of course, as the foreign key. City, state, region, district, country. Yeah. So as you can see here now, we have reduced the size of this. You can see now, right? We've got just 10 columns left. So we've reduced the size of this table, okay, by breaking it down into extra dimension tables, right? And one other thing we want to create is a date table. So you can always get an M query for a date table online. So I got my online. Let's create another query here, and I go to advanced editor. So all right, so in the advanced the advanced editor, we remove this and replace it by the code for. So I mean, you can get this code online. Just go on Google and say n query for this table and you get it. It's as simple as that, right? So that's it, done. And yeah, we got this. So we created a blank query to run over it again. Create a blank query where I want to put what I want, and I think this data runs back to 2001, if I'm not mistaken. I mean, you can expand the date as much as you want, and I think it runs down to 31st 12 2022. Okay, and we say evoke, and let's see, we've got it here. I mean, we've got the whole of the date table here, as you can see. So it means that this date, right, will serve as the primary key, right? So let's do a bit of transformation for the data set. This is date. We convert this to date. Where is it now? Date. This is year. It should be in text because in no way would we be adding it up. This is quarter. Should be in text. So whenever you see Power Query showing ABC 123, means it's quite confused. Text here, month number, text, month, text, day of the week, text. Okay, so we have this, and we can see that every record in this date is unique, right? So serve as like something like primary key that can join back to the date you have here. So the date you have here, you see that it is in date time format. So one of the best ways to do, so let's rename this, let's call it dim date, right? One of the best ways to do this of this date is you can convert it to say date time, right? Replace current, right? Yeah, so we have this. So we don't have issues, right? So I think we are done. We've created our dimension tables. Let's close and apply. All right, we have it loaded in, as you can see here. All the dimension tables are here. Well, now let's check it out, right? I assume or I expect that Power BI automatically sort the relationship via the primary and foreign keys we have in the model and create it. So let's check it out. We come to the model view and drum rolls. Yeah, we have it. Let's zoom out a bit. Yeah, and you can have it. I mean, the team date is here. I mean, and this is basically what star schema is all about. You've got the fact tables in here, and we've got the dimension tables just around, just around it, and that's basically what star schema is all about. So what we'll do is we'll connect this dim table. But before I do that, let's go check it out on this place. Let's pick matrix. What do we do now? Let's pick a fact, say the unit price now. let's see that net price. Yeah, so we have this, and let's try to analyze it by, say, customer name. Customer, let's say first name. That should work. Good. As you can see, we have it. Customer name, blah 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 blah, right? And let's put it to, let's go to dim date. Let's see it by date. Okay, let's put the date in columns. Does that work? Oh, there's an issue there. Let's do this. Okay, let's remove the name. Okay, and we put, say, the year now. Okay, in the row. What can you notice now? From 2001 to 2022, you can see just duplication of the of the total. So it only means that there's an issue with the relationship, or in essence, it means there's no relationship between the dim date and the fact sales tables, right? So it's either you have this duplication or you have it as blank. So we go back. If you remember, we don't have this connection. So what do? We try to create it, right? So remove this, and it should work. Good. One to many. Make this relationship active. A single. Great. And yeah, we have it. Let's go back and see the magic, right? Absolutely beautiful. You can see here that's updated. So that is our star schema created. We can see that the model is working. Convert this to, say, line charts, and you can see it. And that's it for this video. I hope you found this walkthrough helpful in understanding the basics of normalization and data modeling in Power BI. If you found this video helpful, please give it a thumbs up and share it so others can benefit as well. Don't forget to hit that subscribe button if you haven't already, and ring the notification bell so you will be notified every time I drop something great. Your support helps me create more content to help you on your data journey. Thanks for watching, and keep growing with Data Doctor. Until we meet again in the next video, stay curious and keep learning.